Good morning, welcome to Introduction to Inventor. My name is David Bartram. I will be going through Inventor with you. So we'll get started looking at some of the features or issues as a manufacturing you regularly come across. So for instance, you'll regularly come across things like how do I sort out product complexity, quality of documentation, reduction of costs. Now Inventor's got some features built into this which can certainly help you. So I'm going to go through a few of these and also give you an introduction to some of the features that Inventor's got, starting with some very simple components and looking at some of the more complex features to help you design more efficiently. So we'll look at a little bit of business strategy. So looking at the very top of this chart for the moment, it's identifying what are the key business strategies for manufacturers. So differentiation of products through innovation, and differentiate products through customization. Those are the top two features that help distinguish manufacturers. Now using Inventor we can help to achieve those. So what sets one performer apart from another? So revenue growth. A top performer should be achieving around 22%, and profit margin growth you want to be achieving around a 17% growth. So how does Inventor tie in with all of this? So we look at Inventor as part of digital prototyping. So what's meant by that is the whole cycle of how you get a product from scratch on maybe a piece of paper through to a final product. Now with Inventor you can start by doing your sketches, you can then create a 3D model, but with that you can do testing, you can see how parts fit together. This can reduce the amount of time it takes to produce a final item. Maybe it reduces the amount of time it takes to produce a prototype, or reduces the number of prototypes required. Also you've got tools now to help you control parts. You can also visualize better how parts fit together. So this graph here is a nice little example that shows the difference between what you traditionally call 2D drafting versus 3D drafting. So looking at the green, this shows what you would typically do in AutoCAD. So every time you have a change, your cost goes up and your productivity goes down. Ideally what you want to do is reverse that trend. So looking at our cost and productivity, we want them to be the other way around. So as you're going through manufacturing, initially you're starting your design and engineering, your cost and productivity are going to be the same. As you start testing, you want your productivity to always be higher than your cost. And as you're manufacturing, you've got the greatest scope there for a cost to incur. So you want to obviously have that greatly reduced. So that's the end of the slides. I just wanted to show you those to give you a rough idea. Got some of the benefits. Now we're going to look at Inventor itself. So this is a typical sort of model that you can do in Inventor. It just uses several assemblies, sub-assemblies, parts, and so on. Now what we're going to do today is look at initially how you can create a very simple component. Then we're going to look at this wheel arch here and then see different ways we can develop that. So we're going to take this idea of the wheel arch and we're going to make a plastic component out of it. We're then going to look at how you can use the features of Inventor to take it into your 2D drawing environment. Because one of the biggest issues you find as a draftsman or an engineer is you draw up your model, you do your drawing for it, and somebody comes back with a change. Now if you're doing this typically in AutoCAD, you may end up having to change 20 odd sheets, which obviously adds time to your project. In Inventor, if you make the one change in the model, everything will update in all your sheets simultaneously, reducing the amount of time and therefore saving you costs. So we'll get started. What I'm going to do first is create a simple part in an assembly and show you how you can make things update. So with Inventor, I'm just going to create a new component. So you've got various standards you can choose from. So English is Imperial, we've got metric here. So I'm going to create a simple part with Inventor, you always start by doing a sketch. So you're defining the outline of the profile you want to create, and you do it in work planes. This just positions it in space. So the center point is 0, 0, 0. So you've got various different tools to help you draw efficiently, very similar to AutoCAD. So I'm going to do a simple box. Actually, I'd make it slightly longer at the top so it's very easy to change. Double click your dimension, and you can put a new dimension in there. So there we go, I've now got a box. So I can finish that sketch. Now I've got a profile, I can use my 3D tools to start creating it. So I'm just going to pick extrude that up, and I can choose a distance. So I'm going to extrude that 50 millimeters. So very simply, there's my first component created. Nice and simple. What I'm going to do now is decide, okay, I want to now maybe hollow this out. So I could draw another sketch, cut bits out. But what I can do is use some of the inbuilt features of Inventor to speed me up. So I'm going to say shell. So I can say I want an even wall thickness all the way around of 2 millimeters. So I now want to remove a face. So I'm going to choose that face. I've now got a box with a wall thickness of 2 millimeters all the way around. So I'm going to save that. As box _1, because I've already got one there called box. I'm now going to create a new assembly. So here I've got standard.iam, that stands for Inventor Assembly, and go create. This takes me into our 3D environment. So I'm going to place a component into the environment. So I'm going to put my box _1 in there and go open. What I can do is look over here at the orientation. I can see it's coming in not in the orientation I want, so I can rotate it around an axis, and I can ground it at the origin point. So I've now got my component created as I wanted. So I've now got a part in here, but I may want a lid now for my box. So what I can do is I can update this and create a component whilst in the assembly environment. So you don't have to create all your components separately and then work out on a piece of paper how they're going to fit together. You can work with other parts and use the features of those other parts to make you slightly more efficient. So I'm going to create a component. This time I'm creating it in a slightly different way, so I'm creating it in the assembly. I'm going to call this one lid. Again, I can choose what standard I'm working to. So again, I'm going to choose a metric part. I'm going to make it just ordinary millimeters and go OK. And now I need to specify on the screen where do I want to create it. I'm going to do it on the face. It then takes me into my part environment. So I'm going to start a sketch. I'm going to pick the face. Then using project geometry, I can just use geometry from the face below and then finish that sketch. It's created the work plane because that's the reference. Now all I need to do is extrude this sketch profile. So maybe do it 3 millimeters and go OK. Right click, finish edit. I've now got a lid for my box, so I've got two separate components. Now this little symbol over here is telling me that the lid is what's called adaptive. What this means is if I update the box, the lid will update to suit. So it saves me time and reduces the amount of time I have to spend editing dimensions. So to show how that works, I first of all save this assembly. If I go back to my box, before I go right click on here, show dimensions, you can see that 150 dimension there. If I just change that, make it 100, and update the box obviously shrinks down in size. If we go back here, you can see at the moment it appears that the lid hasn't updated. If I go to the top of the screen, put a little update button, if I pick that, immediately the lid updates to suit the box. So we're reducing the amount of information. I haven't had to type any sizes in for that lid. That lid is using all the information from the part below it to update. So again, we're reducing the amount of information. So what we're going to do now, if I close this down, is we're going to start looking at this wheel arch on this front loader. This is like the rear end of a front loader machine. So the engine's here, this is the back where the lights are, with a wheel arch for each wheel, and so on. So we're going to concentrate on this wheel arch. You can open up parts of the assembly from one area and open up to have a look at. So this one's constructed out of lots of pieces of metal, fixings, bars, tubes, and so on. So we're going to do a simplified version. We're going to say we're going to do one which is perhaps constructed out of a plastic moulding. So to get started, I'm just going to create it out of one component. So I'm going to go New at the top and choose Part. You'll notice over here we've got our view cube. This gives us the orientation on the screen. So what I'm going to do is start by doing a sketch on the XY work plane and start drawing up my profile. So I'm just going to do a 2-point rectangle. The idea in Inventor is to do very simple sketches to get you started. So I can start dimensioning up. Now in Inventor there's only one main dimension tool. It will automatically recognise whether things are horizontal, vertical, or their angles, and so on. So I'm going to put a dimension in here of 1730. You can zoom extents. Then over here I've got constraints. This is the same as AutoCAD. If you used to do parametrics in AutoCAD, you'll recognise these symbols here. So they're exactly the same constraints you have. So I'm going to put a vertical constraint in from the bottom edge of here to there to locate that centrally. What you'll see now, if I move one side, I can't. Move the other side, I can. So I've now locked it in position. So as we put more constraints in, it will get locked down further. So I'm now going to do a little bit more sketching to create the shape I want. So going in, you can pick lines, you can also pick edges, and we can put in the dimensions that we require. So you can see that I've started putting in some dimensions. What I can do now, I can start trimming off the bits I don't want. We're keeping our sketch simple, so the trim tool is up here. You get the same 2D sketch menu in whatever part of Inventor you're in. So if you're doing a sketch, the menu's the same. It keeps it nice and simple and keeps you familiar with the areas you're working on. So we're going to pick trim. I'm just going to remove that edge, and automatically it works out what to cut. So you don't have to specify 2 lines to cut between. You can say, right, remove that line and remove that line, and it will still associate the dimension to where it came from. I'm going to do the same over here as well. I'm going to put some horizontal constraints. And I'm also going to put some perpendicular constraints. So I've now started to constrain it. If you look down the bottom right hand corner of the screen here, it now tells me my model is fully constrained. So I'm starting to develop the shape of my model. I'm now going to put some fillets on here to finish it off. So I'm going to create some fillets, 700mm diameter, or radius rather. Actually, I just want to put 1 in there, so let me just undo that. So there's my profile I've created. So I just finished that sketch. So now we've defined the profile, I can now start to extrude stuff. Have you noticed what I tried to do was, with my work planes, draw my sketch so it always intersects between the work planes. That just means when I come to modify it later on, it's much easier to identify where I'm working. So it's just a good practice I'm trying to follow. So I hit extrude now. I'm going to make it into a 3D. So I'm going to extrude it at 570mm. And I'm going to extrude it symmetrically about the work planes. So 570, there we go. So it gives us a little preview first. So I'm going to go OK. I've now got a solid block. So what I'm going to do now is start to develop this a little bit more. So I'm going to start putting on some features. So I'm going to put some fillets on. So I'm going to put some 6mm fillets, and I'm going to pick the edges I want to select. So on that edge there, that edge, and that edge, I do some 6mm fillets, and go OK. You can see there automatically it's rounded off nicely for me, the edges. So I've now at the moment got a solid block. So I can now set the materials. So I could say, right, let's make it out of some plastic. Let's make it ABS. If I don't like the colour it comes in with, I can change the colour. So let's say I want to make it black. So I've now got black ABS. For the moment, I'm just going to change it back to as it was, so I can see it a little bit more clearly. Sometimes it's easier to make it one colour while you're sketching, and then change it to the colour you want afterwards. So now I've got the main block, and I've set the material. You can actually look at the properties. So if we go to the physical properties and update them, because it knows it's ABS, at the moment it's a solid block. It says it's 1,121 kilograms. So I'm going to go through the processes, and after I've finished creating the process, we can review the weight and see how it's updated and use that information. So we're going to use the shell command. I'm going to go through, pick the base. I'm going to say I want the wall thickness to be 3mm, and go OK. I've now hollowed out this component. If you notice as well, it keeps the bend radiuses on the inside because it's hollowed out and followed the shapes of the bend radiuses we put on the outside. If I go back to look at the weight now and pick up date, it's only 18 kilos. So it's reduced the weight by removing the material. So it's able to calculate all of that for us. And we can actually use this information in our drawings later on. So if putting the weight in your drawing is important for you, you can use that information and it will update. So if you change your model, your notes in your drawing will also update to suit as well. So I'm going to do a sketch on this face and remove some more material to make it look more like the wheel we were working on. So by picking on the face, you can automatically project all the edges and use that as geometry. So I'm just going to draw roughly first the shape I want. I'm not too worried exactly what the actual dimensions are. I'm just doing something which is approximately right with the number of lines, which is nice and easy with Inventor. So I've got that shape there. Once I've got the shape, I'll then start putting in the dimensions, which makes life nice and easy for me. With my dimensions, I'll put a 60mm one there. And 55 in there. I can always readjust the height. So you can see now I've fully constrained that. It's all turned blue. Down at the very bottom of the screen down here, it says fully constrained. What we can do now is put a couple more fillets on, and that will generate the sketch that I want to use for cutting. So again, 700mm, it recognises it from last time, so again it speeds you up. So I pick the lines I want, and then I can just finish the sketch. So using my extrude tool, I can pick the profile I want. I can then say cut, I can say to next and go OK, and that will remove everything. So I've now created the profile I'm working on. So I've now got one component. If I want to, I can go through and put more fillets on, but for the moment I'm going to look at the inside. At the moment this could be a fairly flexible plastic component, so I may want to put ribs in to stiffen it up. So we're going to look at some of the features that Inventor's got for speeding up and putting stiffening in. I could manually go through, draw squares, extrude them, but there are actually tools that can help us do this. So looking at the inside, perhaps I want to put some ribs just along this surface here to increase the strength. So the first thing I'm going to do is put in a work plane from the base up here. You can manually drag it and look at it. I can then say, right, I want to do maybe a 75mm offset work plane. So I'm working on here. I can now do a sketch on that work plane to start working on it. So what I'm going to do is draw some ribs up. So to do that, first of all, I'm just going to draw some lines. So using my constraints, I'm going to put a coincident constraint to the middle. I start developing my sketch. So I'm not too worried initially about the sizes of any of the lines. So I'm saying nice and flexible. The only thing I'm constraining initially is the position of the horizontal and vertical which cross the center point. I'm just making sure these stay within inside the boundary area that I'm working in. As you may have noticed, if I just delete one of these lines, as you draw a line, Inventor tries to help you. So you can type in the length, and I can toggle then and type in the angle. But Inventor will also, with this little symbol you can see down to the lower right of the line, if I move an angle it disappears. As soon as I snap almost vertical, you get the vertical constraint symbol. So Inventor is always trying to help you by putting in constraints it thinks are relevant. So I'm just going to put in that line and move these two roughly in position as well. You can drag them and make them longer. So what I've done, I've started creating the profile. I'm going to apply some constraints now to make it suit what I'm after. So I'm going to use the symmetry constraint, or symmetric. So I'm going to say that line and that line are symmetrical about this line. So if I now move those lines, you can see what effect that constraint has. I'm going to do the same in the other orientation, so that line, about that line. I'm then going to apply a few constraints, not too many, just to roughly position where I want the ribs to be. So from there to there, I'll say it's 100mm. From there to the top of that line there, I'll say is 220. And there, I'll say that's 150. So these are going to be the rib positions. Obviously I could put a lot more in, but I'm just doing a few for this example. So what I'm going to do now is put in a center point. So at each of the points, and the intersections, using our point tool. So to get the little menus coming up, you've got right click, so this speeds you up, makes it slightly faster. So that right click there, you can customize this menu, so as you get used to Inventor, you can work much faster. You then right click and flick up, and that gives you what's called a gesture command, and you can choose commands much faster. So I'm just going to finish the sketch. I'm going to toggle off the visibility of the work plane. So I've now got my structure created. Using this sketch, I can now create ribs nice and quickly. So under the Create tool, we've got more tools here. So you've got Sweep, Loft, Coil, Emboss and Derive. The last one I've got here is Rib. This is the tool I'm going to be using. So this Rib menu which has come up is the one we're going to be using. So the first thing I need to do is choose the lines. And you can see immediately it just extrudes the lines to the extents. So because I put the work plane just below the surface, so it's below this edge here where the cursor's displaying at the moment, because I did it below that surface, it's going to the next edges available. I can then put a draft angle on the ribs, so perhaps I want to put a 4-degree draft angle. So if I just zoom in a little bit, you can see the draft angles have now got a taper. I could then say I want the bosses to go in. Now the bosses are going to be at the points I put in earlier. So I can specify their diameter, so maybe do a 20mm diameter. You can see they appear. I can also put a draft angle on those as well. So I'm going to add a 4-degree draft angle so they match up with the ribs we created. So I'm going to go OK. So I've now got my component created. Go back to our properties, go to physical, update those now. You can see it's increased a little bit in weight because we've added the ribs on, so it's now 11 kilos. I can now do a drawing of this part. So if I was happy with this component, so I'm pleased I've done all the parts I want to that, I can then start drawing this up. So I'm going to do a small 2D drawing. So I'm going to save this first. I'm going to call it wheel arch. We go to new at the top up here. We've got various different templates we can choose for creating our drawings. So within the drawing environment, you've got different standards. So you've got ANSI, ISO and so forth. What we don't really recommend is working to the standard you normally do, copying a template, and obviously you can configure it to your company border and so on. For this example, I'm just going to choose an ANSI standard, just because I know it's the third angle off the top of the head, so I'm just going to pick that one very quickly. So I can immediately just go in there and place down a component. It will automatically choose the last one you've got open. However, you can go through, choose any you've got open, or you can browse back to the folder where you've created your parts. So I'm going to place my wheel arch in, and I can create some views nice and quickly. Those are my views created. I can also do an isometric view. There's my isometric view for my part. If I want to, for these views, so I find this view here, if I find the model and right click, I can actually show the centre of gravity for this part. So on some components it's important, especially large stuff, so if you're doing maybe large steel duct work, it may be important to understand lifting and handling diagrams. Where's the centre of gravity for that, so you can work out where things are. All you have to do is put it onto a view and pick the centre of gravity. You can view it in the model as well, if it helps you visualise. So you go to view, you can turn on the centre of gravity, and you can see it there. Then you can use your measure tools, and you can measure your distances. So in our annotation area, we've got some dimension tools. So I can dimension to the centre of gravity from sensible points. And again, you may want to do it in another view as well. So again, I just expand the view, expand it down to I see the model, right click on the model, centre of gravity, and then I can finalise the position of the centre of gravity. So it's nice and simple. And you can set up the number of decimal places, all the points, and the styles exactly as you want it. So we're going to look at another quick way of creating some of these components. So if I go into this part here, I'm going to open up this part I'm called master. So this is very similar to the part I created before. So if I just hide some features I've applied, you see I've got the same shape here. If I create an edit feature, I'm going to make it 570 again. So that's the same shape we had before. All I've done now is draw a profile on. I've used what's called a split command, which just means I can separate one face from another. And then I've used the chamfer tool, which is in here, to put chamfers on the edges. So that's created me a component. What I've then done is created some new parts. So for instance, I create a front panel. What I can do, if I just delete this component, I can bring in my model. So if I go derive, find my master component, I can bring that in. And I can say, right, I want to bring this in as a surface, and go OK. I can then say I want to do a sketch on this face. So I'm now sketching on this face. And I can finish the sketch, because what it's done is automatically projected the edges for me. Go back into my sheet metal tab, because what I've done this time, instead of creating an ordinary part, I've chosen the sheet metal template. So when you're in new, you can choose sheet metal. This gives you different settings. So what I can do, I can configure this and say, right, what sheet metal sizes do I want? So here I've chosen 3mm mild steel out of my list I've created. I've then chosen the face, so I can pick that and automatically recognise, make sure it goes in the direction I'm expecting, go OK, and it immediately creates a face for me. I can then do another sketch on there, finish that sketch, pick face, go OK, and it creates a face for me and also puts in the bend radius. I can then hide the master component by turning off the visibility. I've now got a sheet metal component created very quickly, and I can create a flat pattern for that. I can toggle back to my folded component. So I've created the front panel. I'm also going to create rear panel now as well. So again, I'm going to go for the outside panel. Oops, sorry, wrong panel. Let's just close that one down. So for the rear panel, again, I've derived it in the same fashion as I did before. So I'm just going to do a sketch on the back here. Finish the sketch. Choose my sheet metal style. Again, I've chosen 3mm mild steel. Pick the face. Make sure the direction arrow is correct. All I've done, I've created the inside shape of the wheel arch. And go OK. That creates my component for me. And again, I'm just going to toggle off the visibility of this master component. I'm going to save that. Then the last one I'm going to do is just create the top panel. I've already created the sides. So I'm going to choose my top panel. So again, I've already derived the main master part into the assembly. So this time I'm going to create this complex curved panel. You may think this is slightly difficult to do. There are actually tools in sheet metal which speed you up. So all I'm going to do, pick Start Sketch, this time pick the side. This automatically gives me edges I can use, but I need to turn some of them off because I'm not going to use them all. So I'm going to do a right click selection from right to left. So it's the same as AutoCAD, that enables me to select everything. I'm going to turn that into construction. So up here I've got construction button. What construction does, it means I can create a line, but it won't be used to generate the profiles that I want to draw with. So again, choose the other parts I don't want to use, make those construction. So now I've just got a line going across here in 3 parts. So I can now finish my sketch. Make sure my sheet metal style is set up, which it is. I've used 3mm mild steel. I'm now going to use this feature over here called the contour flange. I can choose a profile, excuse me. I can make sure that my profile is going the correct size, so I can see it's going above, which is good. Unfortunately, it's going in the wrong direction. So I can, down the bottom here, I can flip the direction. Now for the distance here, it tells me what is the distance I want. Now earlier on, when I modelled the part, I defined it as being a certain depth. So if I list my parameters, I can choose the depth and go OK. So I've now got my curved panel. I can turn off the visibility of the base part. Then I can create my flat pattern. That unfolds my component for me. If I right click on it, I can export the face, so I can save it as a DXF file if I wanted to. Send it to a laser cutter. I can go back to my folded part. So I've now created all of the components I'm going to use to create my wheel arch. So what I'm going to do is just save that and close those panels down. So what I'm going to do now is create my wheel arch assembly. So at the moment I've got nothing in there. I need to place my components in the right place. Now because the sheet metal one, I based it all upon one component originally, the datum points are all at the same place, which makes life nice and easy. So I'm going to place in some components. So I'm going to choose the components that I want to bring in. So those are my components. I'm going to open those. So you can see all those panels I created come in. I'm just going to right click, place grounded at origin. And you can see immediately I've now got one assembly, all the parts are in the right place. If I zoom into the corners, you can see the panels meet absolutely perfectly, so the joints are absolutely perfect, and it's ready to be in a state where you could weld it up to create your welded assembly. So the next step, what we're going to do is bring in some more components. So this time I'm going to bring in a mud flap, so I'm going to place a component in. So I've got a front mud flap here. So at the moment I can place it in place. So far we haven't seen what's called constraints. These are things we use all the time in Inventor to position items and set and fix them in place. So that panel is next to that panel, or that component related to that component off a certain distance from that edge to that edge, and so forth. So looking back at our assembly here, we've got our wheel arch. So I'm going to position the wheel arch on this face here and put some fixings in. We're doing a slightly simplified version. So I'm going to put the wheel arch on using my constraints up here. So this is our constraints dialog box. I'm going to say this face here, constrain to that face, and it pops around. And I can apply that. I can then say edge, I want to be flush. That edge is flush to that edge, and it pops in place. I can then put in an offset. So if I apply, I can measure the difference. So if I go to my inspect tab, I've got distance here, measure from there to there, so I can see it's 90 mil. If I go back to my flush constraint here, I can edit that, and I can put an offset of 45, which centers it nicely for me. I can then see I've got one constraint left to apply. I can show how much freedom that part's got by turning on its degrees of freedom up here. A little arrow appears. That gives me a visual clue as well. If I can't quite work something out, I can turn that on. Now what we're going to do now is apply in some fixings after doing our last constraint. So we've got one more constraint to apply. So from there to there, then I'm going to do an offset of 25 mil. So if it goes the wrong way, you can just toggle, put in minus. Actually we'll make that larger because it looks a little bit short. So perhaps we'll change that to 75. There we go. So I've now got a mud flap in there. So I now want to put some fixings in place. Now we've got some tools in the assembly environment which speed us up. So I'm going to look at some of the design accelerator tools. So we go to the design tab. We can do things like bolted connections. We've also got things called frame generator which enable us to create some profiles, and we'll put the tubing and pipe along those. So here I'm going to put bolted connection. This loads up a menu. So the first thing I want to do is say I want to put a fixing on from one face. So let's choose this face. Now I need an edge. So say from there, I'm going to do 75. Actually I'll need to divide it by 2. So you can do that and hit the tick. I'm then going to say from that edge there, perhaps I just want to put a dimension in, offset by 50 mil, and go OK. That's now put in our distance, and now I need to say where's the termination, so where's it going through to? So it's going to be to this face with the other component. So I can pick that other face. I can specify what thread and what hole we're going to have, so perhaps M10's maybe a little bit large. So perhaps I'll put some M6 size in there. So it's going to put some holes in to suit M6 fixings. So the first thing I want to do is add a fastener. This takes a couple of seconds to load. What it's doing, it's going to what's called Content Center, which is a library that comes with Inventor of nuts, bolts, washers and many other type of standard items you purchase off the shelf, which you can utilize and are all done to the correct standards, and you can bring them into your model. So the first one I'm going to choose is a bolt. So there our menu's loaded up, so I can go in here and choose what's available. So you can see the various standards. So I'm going to choose one like that. So I've put in the bolt I want. I've chosen one with a lip around the edge of it. So I go to the other side. I'm going to choose the fastener that I want to put in there. So that's going to whir away for a second. So I'm going to put a washer in the other side to start with. So I'm just going to choose a plain washer. Maybe add in a spring or a crinkle washer. So if it comes in by nuts by default, you can always change that. So I'm going to choose washer. You don't have to have every single standard loaded. I've chosen to have everything. Apologies if you lost the screen for a second there. So we're just putting in our last component. So I'm just putting in a nut to finish. So I've now got in there my bolt. It's automatically putting the holes into the components for us, and then I'm putting in a nut, a washer, and the nut to finish. So I'm just going to go OK. It's going to create automatically an assembly and place this into what's called my project location. Whenever you're creating anything in Inventor, you create a project to start with. So I'm going to go OK. It then puts in the holes and the components for me automatically. It's then processing the information and putting in the fixings that I've selected. And it'll automatically choose an appropriate size bolt as well. So you can see there it's put in the assembly, it's put in the parts I've chosen, including the washers. If I open the parts up individually, you can see as well, it's actually put in the hole for me. So you don't even have to worry about adding holes in. I'll show you one last little feature, and then that will conclude the presentation, and then I'll answer any questions you have. So I'm going to create one last drawing. I'm going to do a base view on here. So up here we can choose which side we want to do. So this relates back to our view cube. If you're not happy with the side, you can go in and we can orientate the view we want. So I'm going to say go to one side. So that's the side I want. I'm happy with that view. I can then place it on my drawing. So I wanted to show you a little bit about some of the information you can take from the model. So I'm just going to do a note very quickly. So from the model, I can take physical properties. So I'm going to put this mass in. So I can say estimated weight and insert that into the model. So automatically, by placing the view in and choosing which view you want, you can bring model information in that updates. So you can see here the weight's going to come in. That's 6.5 tons. Now there's one last bit I'm going to show you, which is one of the advantages of using 3D environment. So we've created this wheel arch assembly. So I'm just going to view the drawing of this. So there's my drawing, views created. And then I'm going to put some dimensions on. So I'm going to do some overalls. Get your dimensions to line up nice and easily. So we've got some dimensions there. Let's put one more in there as well. So we'll look at this 576 dimension. Now it could be that when it comes back to the model here, the customer comes back and says, actually we're going to put wider wheels on our assembly now, so we now need to change the width of the wheel arch. If you'd drawn the work in 2D, you'd have to go through each of those panels and each of the drawings you've done for those panels manually and update them all. What we're going to do is look at a slightly more efficient way of doing this. So if I just save this assembly, or this drawing rather, so I'm going to call it wheel arch assembly drawing. If I go back and look at the wheel arch master part, so let's go back and open that up. So this was the part we used to generate our assembly. What I can do, because I based all my components off of this one, if I change the width of it, so I go back to my extrusion, that's my depth. If I change that to maybe 800 mil, that automatically increases in size. If I go to the assembly here and pick update, all of the parts increase in size as well. The only one which hasn't is the wheel arch, because I didn't base that upon the assembly. If I now go to my drawing, that's automatically increased in size, and so have the dimensions as well. The only thing you may need to do is just reposition some of your dimensions back in place. So hopefully that's answered some of your questions. So what I'll do, I'll just turn on the speakers, or you can type in the questions, and if you've got any questions, let me know. Just bear with me 2 seconds. So if you've got any questions that you'd like to type in, please feel free. I've unmuted you as well now, so if you've got any questions over the phone or online, just ask away. Okay, so I've got a couple of questions to come in regarding loading of components. So loading of components is quite straightforward. So if I create a new assembly, so if you want to load a component into Inventor, if you've modelled it yourself, it's very easy. You just go into place, and this will take you to your location where you've created components. So if I've modelled up something myself, like an inside panel, I just go in there and place it at a grounded position, and that brings it in. If I want to place in a component like a nut, bolt and washer, I can go place on Content Center. That brings in a menu like this. I've got things like nuts, bolts and washers. I can bring those in. If there's a feature with a thread on it already, I can then place that in, go OK. So I can place different components in like that. You can also bring in components from other people. So for instance, if we go up here, you can open up different components. You can see the various different extensions of files you can bring in. So files from different CAD packages, the step files, CATIA files and so on, you can bring those in. So I've got a question about bridge design. Does it apply to Inventor? So there are things you can do in Inventor. You've got things like lots of tools for nuts, bolts, washers and fixings. So you can apply those in. You can also do things called frame generator, where you can draw the shape of something. So you can draw the profile you want a beam steel shape to follow, and then by clicking those beams you can join them together and you can trim those up. Any other questions at all? So Lucas, I can see you've asked a question for steel structures or concrete structures. Is there anything in specific you're requesting on that question? Okay, well, I haven't received any more questions, so hopefully that's provided you some useful information. If you have any more questions, please feel free to get back in contact with us, and we'll provide you with any answers we can. So thank you very much. That concludes the presentation.